We have a guest speaker tonight, Rhys Howard from Highlands Insulation. And Rhys has a lot of expertise in what has been described as possibly the first step in retrofitting your house. So I have heard some very wise experts in the energy space say that insulation and sealing up your home is the first place to start. I wanted to show you the before and after. So that's what my roof looked like before. The insulation went over the top of the existing 30-year-old insulation, which had compacted to the point of not being usable. I can tell that I'm using less energy. I consult my app and I can see how much power is being used, and my heat pump is cutting out much earlier in the day because it's reached the level of comfort that I've set it. Rhys, I'll hand over to you to tell us what we need to know.
Sure. Well, it was interesting looking back at how bad the ceiling insulation actually was in your place, and that first photo with the ceiling insulation bats, you actually had none in that section. So you were always going to get a really big result going from nothing to the R5 that we put in. I'm very glad to hear that you've really noticed a difference. It's good to get feedback when I do an install and actually see the data. I often do these calculations for people behind the scenes, and you expect people to be saving money on their energy bills, and for actually people to be tracking it like yourself is unusual. Most people just say to me, oh yeah, it feels warmer, but they don't actually have the data to back it up. Tonight, I feel that most members of WinZero have some idea of what they should be doing with insulation in their homes. My background is mostly commercial and industrial. So I come from a technical background in working out the benefits and the energy saving that the insulation is going to provide. So when I think of homes, I think of them as a system, and you want the system to operate as efficiently as possible. There's reasons why the industry provides recommendations and uses products. You've probably all heard, of the products. You've probably heard all these terms, but don't really understand what they mean or the science behind them. So I'm going to chat a bit about the science behind insulation and some of the industry jargon that trips people up. A good example is Bunnings sell a product called Earthwool. I'm sure you've all heard of it. It's what we installed at Chris's place, the brown fiberglass bats. And I was down in Goulburn Bunnings buying one bag of insulation because I'd messed up on a job and under-ordered by one bag. So put my tail between my legs and drove to Bunnings to buy a bag. And a friendly customer service man was helping me put that on my ute. And he made a comment, oh, it's a shame that we can't make this stuff here in Goulburn because the sheep are just out across the road. I looked at him and I said, sheep? What do you mean? He said, oh, isn't this stuff made of sheep's wool? And I was like, no, sorry. You're obviously quite confused. And I just think even if the Bunnings customer service person doesn't understand the product they're selling, what hope do the rest of us have if you're not in the industry? I've got two young kids, and what's the world going to look like for my kids? That just really blows my mind. And I'm proud to be running an insulation business and doing my part for the environment, which gets me to insulation itself, which is really a kind of silent hero in our homes, I think, in that no one ever looks at it or thinks about it, but its job is to regulate the indoor temperatures by preventing the exchange of heat or slowing the exchange of heat. And in an ideal world, we'd have no heat transfer through the walls and roofs in our homes. But because physics doesn't allow for that, we simply strive for the best products for each situation. And there's probably far more insulation products on the market than most people realize. And they're each unique and they each have their own applications, whether it be to do with temperature or how they fit into a wall or a ceiling or a floor. It's really quite overwhelming. So hopefully next time you look at a bag of insulation or you're walking around in Bunnings, you really understand what they're saying on the fine print. So insulation products are generally classified because their coefficient of thermal conductivity is very low. Now, the coefficient of thermal conductivity on every piece of data you will see is called the K value, and I'm going to refer to it as the K value from this point on, and it's a really important thing to remember. So you'll see if you have a look at an insulation product data sheet or packaging, even things like plasterboard or brick will often have a K value, and K value is measured in watts per meter Kelvin. It's a measurement of the energy transfer through a material. It's measured in a NATA accredited laboratory in accordance with one of the Australian standards. So all insulation products are measured equally. There's an Australian standard which tells a NATA accredited laboratory how to do it. And then a product is given a K value. So plasterboard, bricks, concrete, timber, they all have their K values measured, as do all insulation products. And the lower the K value, the better the material is at slowing the transfer of heat. So aluminium or copper would have an extremely large K value, but a product like vacuum panel would be a very small number. So the K value allows us to judge how good an insulator or material is, but it does not take into consideration the thickness or the shape of the material, and therefore it doesn't allow you to compare two products side by side. And this is what the R value does. And that's the number that allows us to compare products regardless of type or thickness or shape. So you could compare the R value on a round insulated pipe to a square insulated duct. And for an engineer, they can simply look at the R value and then make a decision whether they want something that's square or round, what's more efficient. And the R value for a flat surface is simply the thickness in meters divided by the K value. So if you know the K value of a material, you can always work out a material's R value. Let's say, for example, we're looking at the data sheet for some polystyrene, and it'll give you its K value. You can always then work out, no matter what thickness of polystyrene you'd like to use, you can always work out its R value. And so then with the R value, you could say, okay, I've measured that this piece of polystyrene, it's 50 millimeters thick. It's got an R value of 1.22. That's a better insulator than the Glasswool bat of 10 millimeters thick, which is R 0.26. And you can make the comparison that one is better than the other. Why this is important is that some companies, such as Foil Board, which is sold in Bunnings, it's a brand of polystyrene with foil facing other side, they do not give you the K value or the R value of their product. I don't like it when companies don't give you the data. However, they do give you the type of material. And if you quickly research that, you'll see that it's SL grade polystyrene. You can then find quite easily, in fact, you can just Google search it. You can get the K value of that product. It won't be specific for that brand, but they're virtually all the same. And then you can calculate that 50 mil foil board is R1.22. And I know this is very detailed, but it's the underpinning of how the insulation market works. And for anyone who's building or renovating or trying to understand what they're installing, it's really powerful because a lot of builders don't understand it as well. So when we're talking about R values, as I said, you can work out an R value for any material. So for example, I talked to a lot of builders about concrete, and concrete's a terrible insulator, but no one really understands. So you can do a very quick calculation on 200 millimeters thick of concrete slab. The R value is 0.2. It's tiny. Timber's a little bit better of an insulator. And then we get into polystyrene, Glasswool, and we finally end up with some phenolic, polyurethane, and PIR boards, which are excellent insulators. And that's a quick summary of R value, which hopefully makes the next section a bit easier to understand. So I'll get into talking about some of the most common products We won't cover every product on the market, but just the really common ones, because there's some misconceptions and the level of understanding is not quite there. So one of the most common products we use is Glasswool. Glasswool is the current term for the old term that was used, which is fiberglass. The Glasswool manufacturers like Bradford or Fletcher, they've simply moved away from calling it fiberglass and they now call it Glasswool. It's essentially the same product, just a little bit more modern. They use more modern machinery and it's a little bit less itchy and dusty these days. It's really cheap to produce. It's fairly environmentally friendly in that it's just made from glass. A lot of the time it's also made from recycled glass and it comes in various forms. It's widely used in floors, ceilings, industrial settings. There did used to be some concern about formaldehyde added in the binder material of Glasswool. The binder is the glue that holds all the glass fibers together, but all Glasswool in Australia is required to meet very strict Australian standards. So really, we only have 3 choices of Glasswool in Australia. We've got Knauf's Earthwool product, which you'll find in Bunnings, we've got CSR Bradford, and we've got Fletcher Building. They all adhere to the very strict Australian standards, and formaldehyde is essentially not a concern anymore. It really is nothing more than molten glass fibers spun together and glued together with a binder. Now, what varies with Glasswool is the amount of binder and the density of fibers. And that creates a whole lot of different products that are used in different purposes. And we've got a range of Glasswool starting at about 11 kilograms per cubic meter and going up to 48 kilograms per cubic meter, which would be very rigid industrial products that are used in acoustic settings for acoustic absorption. So the ceiling bats that we saw in Chris's place are 11 kilograms per cubic meter. They're very light and fluffy. Then the wall bats that we saw were installed more around 18, depending on the brand, they hold in place in a wall. If you were going to use Glasswool for underfloor insulation, it would be getting up more like 30 kilograms per cubic meter. And that's where we get into territory of acoustic absorption with Glasswool, which is one of its really big uses. So Glasswool is non-combustible in that it does not burn. It's been tested to an Australian standard that classifies as non-combustible. It produces very little smoke and it melts at over 700 degrees, which means it's a great choice in residential homes because fire is a big problem and we don't want materials that melt or burn in our homes. So I think Glasswool is almost a no-brainer in almost every residential home. CSR Bradford, for example, manufacture their Glasswool products here in New South Wales. They manufacture it at Wollongong and Gosford and Ingleburn. The Knauf product, which is sold in Bunnings, called Knauf Earthwool. That's made in Malaysia. It's imported to Australia. Their factory is really quite new and they make a really good product because they're using very new machines. There's a bit of misconception with Earthwool, but I can tell you that it's virtually identical to every other Glasswool on the market. They just dye it brown and add more glue into it to make it less dusty. The next product is blowin insulation. I see it quite often is cellulose blowin. It's a paper-based product. It's essentially minced up paper. It was really popular in the 80s and it just got blown into the home. So they mince up paper in a factory, they add a chemical fire retardant to it and Bob's your uncle. There's absolutely nothing wrong with it. It can be affected by moisture over time. So you find that if you have cellulose blowin insulation, they've probably done it to the level of the ceiling joist being about 100 millimeters thick. And now you all understand the difference between K value and R value. We can go back and say, okay, well, cellulose, we can find its K value. If it's about as thick as the joist, it's about 100 millimeters. We can see that it functions about R2. Quite often it slumps over time and gets below the joist. And so I can walk into a home and kind of look at the thickness and go, okay, that's probably only about R1.5. And I do a lot of topping up where you just put more insulation over the top of that. You can have it vacuumed out of a home, but it's not really necessary unless there's a particular reason. Polyester is another very commonly used insulation products in homes. People often use it for ceilings, walls, and underfloor. in New South Wales, it's always made from recycled material. So in itself, it's not the most environmentally friendly product, but it is made from recycled polyester and it's able to be reused again and again. So if a home was demolished, they could just pull out the polyester insulation and they'd reuse it. It doesn't need to be thrown in the bin. So polyester fibers are thermally bonded together. They don't use a glue, they're melted together. And this makes the product virtually dust-free. And it also means that the fiber bonds are very strong. It can be pinned and stapled onto surfaces like doors or floors. People generally use it where they either need to attach it to something or there's risk of rodent damage. Because the fibers are thermally bonded, the rodents find it very difficult to chew and scratch. And unfortunately for us in New South Wales, Bradford have an absolute monopoly on polyester. A few years ago, they just bought everyone out. And so polyester in New South Wales is quite expensive, but it's still a good product when you need to use it. I use it a lot for underfloor insulation where rats could get into it. But one of the main disadvantages with polyester is it has a melting point of about 200 degrees. So this is a consideration for anyone in their home, whether they're building or whether they've got an older home and they've got polyester insulation installed in the ceiling, is that its melting point is 200 degrees, which means it's a very bad performer in the event of a house fire. It doesn't require a flame to melt. It only requires for the temperature to reach 200 degrees. So you can imagine if someone has a kitchen fire and the flames going up and licking the plasterboard itself won't burn, but it will heat up very quickly, probably to well over 200 degrees in the matter of 20 or 30 seconds. To give you an idea of when they do fire protection testing, they're testing at 1,200 degrees. So 200 degrees, the test would reach that within seconds. And then all of a sudden, if you're in a home, you're in a kitchen, you've got molten polyester coming out of light fittings, etc., it would be a disaster, which is where Glasswool's excellent for ceilings because its melting point is over 700 degrees. Gets us to the next product, which you've probably all heard of, which is Rockwool, which can be known as stone wool or mineral wool. And it's probably the last fibrous insulation product available. It's fairly commonly used. It's quite expensive. It's mostly used in industrial and fire protection applications because its melting point is over 1,200 degrees. And you can use it on products like flues, etc., as it has a surface temperature of 650 degrees. And it's essentially made from molten basalt rock that they spin into fibers and put a binder in it. Really, you'd only see it in domestic buildings if you wanted to actually protect your home from bushfire. If you wanted to protect timbers or something, you could put Rockwool around it and it would actually stop a fire penetrating. So those generally not in a retrofit setting, but those who are building or renovating would probably look at using rigid insulation products. So we can have polystyrene boards, polyurethane boards, polyisocyanurate boards, phenolic foam boards. It's a whole range of those. But to summarize it, it's really only in two categories. Polystyrene is a category in all of its own. Generally, polystyrene is open cell and it allows water to come in. There is other polystyrene products used for under-slab insulation. When people are building new homes, it's important to insulate the underside of the concrete slab, and those products are not water permeable. And essentially what you need to know about polystyrene is that most of the time you're getting a product that does allow water to come into it, and it's not a particularly great insulator. When you compare it to Glasswool or polyester or polyurethane, it does okay. But if you were, for example, choosing between a polystyrene board or a polyurethane board, the polystyrene board would have to be twice as thick to achieve the same R value as the polyurethane board, which is why polyurethane, or you might see the term PIR, which stands for polyisocyanurate boards, They're really good insulators. They have one of the lowest K values of any insulation product. The only product that would be better than them is vacuum panel, which is, I would imagine, out of almost every homeowner's budget anyway. So polyurethane or PIR is about twice as good as standard grade polystyrene. So if you're restricted on space, such as inside a double brick cavity, then a PIR or polyurethane board is a great option. So polyurethane also comes in spray foam form. When they use the term spray foam, it's polyurethane. It's actually exactly the same product that you buy in the cans from Bunnings, except in an industrial setting, they use two different bottles. But it's just a liquid, and they use a blowing agent to expand cells. It dries on contact with the surface, and it's really sticky. So it'll essentially stick to anything you spray it to. It's closed cell, which means that it's impervious to water and has a very low K value, which means it's a good insulator. It's used a lot in industry. Some people use it for underfloor insulation in their homes. It can be great, but it does have some serious drawbacks to consider for anyone considering using in a home. I personally don't do it because I don't like the environmental impact of it. Once you spray polyurethane itself is not made from recycled products. And then anything you spray with polyurethane can then not be recycled later on. So let's say, for example, you spray the underside of a timber floor. When the building's at the end of its life and it gets recycled, all the timber will be taken away to go to a timber yard and be reused. But if it's been sprayed polyurethane, it'll just have to go to the tip. So sticky that you'll never get it off. One of the other issues is that because polyurethane uses a gas to expand a liquid, once the product is dried, it can still degas over time, and it releases the blowing agent into the atmosphere. So, for example, if you've sprayed the underside of a floor, for the next 2 or 3 days, you can still have the blowing agent gas being released. I don't actually know if it happens in Australia, but I know in the US that they recommend that if you have polyurethane sprayed in your home, you don't live in it for 2 days. You might find that Glasswool products smell a bit when you first open the packet. The binder that they use has a certain smell. Really, the final one to touch on is reflective foils, which I don't want people to confuse reflective foils with building wraps or building wrapping, because they're a completely different topic. Reflective foils is essentially just the products that are used under roofs. They're adhered to insulation blankets, and they've only got two purposes: one, to reflect radiant heat, and the other is to provide a vapor barrier or a water barrier. So it's often glued to the back of Glasswool to stop water or vapor transfer going through. And it's a great way to stop radiant heat gain in summer coming down from a roof, for example, and you've got metal roof sheets radiating heat down. The silver reflective foil will reflect the radiant heat, but only the radiant heat. Then an insulation layer would stop conductive heat. So our homes need to protect us from the elements, but they also need to be clean and open to fresh air. You know, we can't just build eskies, which are 100% sealed, as they'll fill with stagnant air, collect dust, and begin to harbour mold and fungus. But in the other, we don't want leaky homes, which lose a huge amount of heat, which is why I think understanding the insulation products we use is probably one of the most important things when it comes to building a home, not only for products that are termed insulation products, but also considering every product as either an insulator or a conductor, for example, concrete or masonry, and how that works in your home. That's really seen when people build passive homes, and they might use clever tricks like rammed earth walls or water tanks to store heat as heat banks. There's so much to talk about really with insulation that I definitely can't cover it all tonight. I might start going through some of these questions. So Clive asked about woolen insulation, real wool. You know, I actually would have no idea where to buy real wool insulation these days. I've been in the industry for 10 years. So if it's prior to that, there might have been products on the market that I'm not aware of. I don't know how wool would go as an insulator. My comments would be that it's an organic material, and generally we want to build with products that are inorganic, so they don't rot, they don't grow mold, and they don't decompose over time. There's also the fire component of buildings these days is very heavily regulated. And I don't know if a real wool product would pass the modern Australian standards in terms of fire rating. They're really very strict these days. Richard has a question about 20-year-old insulation. This is a really good one. So if it's Glasswool ceiling and wall bats that were installed 20 years ago, they're probably still in warranty. So Knauf Earthwool has a 50-year warranty. CSR Bradford have a 70-year warranty, and so does Fletcher Buildings. So if you're using Glasswool, you've got a while to go before it becomes inefficient. Sometimes in a ceiling setting, have dust accumulate on it, or just dirt and residue. You can have rats and possums walk on it, which will compress it. And if it looks compressed, then yes, as we now know, then its R value has been reduced, because R value is a function of thickness. All right, Penny, double glazed Stegbar commercial aluminium windows. Yes, the aluminium frame. No, there is unfortunately no way to retrofit, insulate the aluminium frame unless you're looking at a DIY method. I actually have the same thing in my home, where I had retrofit double glazed windows put into an aluminium frame. And I've thought long and hard about it. And the only way I've thought is to put a foam tape around the frame and then put something over it to cover it. Eric, how economically and physically practical to put insulation to existing brick veneer walls? It's fairly economically viable and practical to put insulation into brick veneer walls. It's fairly simple. If you have access to the cavity at the top, they can normally just be filled from the top of the cavity. There's really only two products on the market that are any good. One is a product called Insul Block, and it's essentially polystyrene cubes that turn your house into a beanbag. They fill it from the top. There is some limitations with that product in that the hose diameter is 100 millimeters. And so they tend to fill from the top, and they struggle to get under windows and anything that gets in the way. And if you do want it filled under a window, they're going to have to go and cut a 100 diameter hole out of your plasterboard inside the home. Your home is also then a beanbag, so every time you open up a PowerPoint or do any work, you can imagine it just spills out everywhere. The other product is from Knauf, and it's on their website. It's called Knauf Superfill, and it's essentially an unbound glass wool that comes in bags, and they put it into a hopper and they just blow it into your wall with a little 20 mil hose. And it's actually a better product. So Jeff's question, does this mean a timber floor on piers is a better insulator than a concrete slab? That's actually probably a more complex question than you realize, Jeff, and it depends on your outcome. So timber floor on piers can easily be insulated with glass wool or polyester underneath. Generally, you get about R2.5. The timber is also going to feel warmer than concrete. The concrete slab, if you're buying an older home that has no insulation under the concrete slab, then yes, it's always going to be cold in winter and cold in summer, as you know, anyone that lives in an older concrete slab home would know. These days, a lot of builders are insulating under the concrete slab. So if you've got underfloor heating in a concrete slab and then you put insulation under the slab, it can actually be arguably more effective than a timber floor on piers. It really depends on your outcome. Chris, you're asking about the insulation products you listed, such as Earthwool made in Australia. So almost every insulation product that you will find is made in Australia, with only a couple of exceptions. That Earthwool, which is the brand that Knauf make. Knauf is an American building company. They're American owned and their factory is in Malaysia, and their Malaysian factory makes Earthwool for Southeast Asia and Australia. So that's imported. Every other glasswool product made in Australia. The only other product which we have no manufacturing of in Australia is Rockwool or stone wool, mineral wool, which is where they melt down basalt into fibers. We don't have any manufacturing of that in Australia. It's probably to do with the fact that third world countries have less safety requirements. And when you're melting a product that doesn't melt until something like 1,800 degrees, the energy requirements and the safety around that probably make it difficult for Australian manufacturing. A lot of that's made in Indonesia. I think they make Rockwool as well in China. So, Noel, are there any BAL requirements or your recommendations for different BAL rated properties? So BAL is bushfire attack level. That's again a very complicated question that would be specific for every home. But what you need to look for is the Australian standard AS 1530.1, which tests for combustibility. And any product you'd use in a bushfire rated home would need to pass AS 1530.1. And it's a simple outcome. It's either combustible or it's non-combustible at the end of that test. So Glasswool and Rockwool come out of that test as non-combustible, and some odd industrial products like ceramic fiber. Everything else is combustible. I've improved my ceiling insulation, but my house didn't have a lot of heating. Can you assess and improve wall insulation? If you've got a brick veneer home, that's very easy to do. You can simply pump or blow in insulation into the walls. If you have a cladded home where the cladding on the outside is attached directly to the frame, which is also attached directly to the plasterboard, then doing blow-in insulation is not really practical and it's a bit more difficult. There are some products in the market. It's still a difficult thing to do in a cladded home. You've really got three options. One is pull the cladding off, two is pull the plasterboard off, or the third is to install insulated plasterboard. So they make a product that is polyurethane foam backed, already glued to plasterboard, and you could just install that straight over the top of your existing plasterboard. Okay, yes, downlights and why they can't be covered with insulation. So especially the older style downlights, which are not LED, they get very hot. And the reason is actually the Australian standard for installing insulation requires a 200 millimeter gap around a downlight. That is for two reasons. One is they don't know the insulation product that you're installing. So if you're installing polyester, which melts at a very low temperature, bad idea. Glasswool melts at a very high temperature, and it's also non-combustible. Most people have glasswool in their ceilings. So the reason that you're leaving a gap is not for the insulation, because it won't melt with the temperature of a downlight, nor will it catch fire, but it will heat up the downlight itself, and the downlight could catch fire or burn out. So it's actually about the downlight, not the insulation. So a downlight has to be IC4 rated. And if it says IC4 rated on it, it's designed to run cool enough that you can put insulation over the top. So I would say most modern downlights are IC4 rated, but if you buy a cheaper one, it might not be. Yeah, Greg's got a question.
It's just about when a house is fully air sealed, you need to have air flow through. Can you tell us about some of the mechanical means of doing that so that we don't lose the heat or whatever's happening inside the actual rooms and get fresh air circulating through?
Yeah, certainly. I'm not an expert on ventilation, but my previous 10 years in commercial insulation, most of that is actually working with commercial air conditioning companies. So I've had a lot of exposure to that world. Are you talking about retrofitting a home, or are you talking about building a new home? It does depend on the construction of your home. If you're on a concrete slab, then you're obviously not going to have any air movement through the concrete. If you're on timber, then you naturally will have air movement, or at least vapor coming up through timber. It might be very slow, but it still occurs. I personally, in my own home, I've sealed up every door and window the best I can. But in that saying that, I have a 90s built home that's so leaky anyway that every time the wind blows, I find another draft somewhere. Mechanical ventilation, I think, is a brilliant idea. I think all new homes should have it. It is fairly expensive to venture down this route, but I guess there's 3 ways to do it. One is that if you have ducted air conditioning already installed in your home, you can easily have a fresh air intake added to that. So currently you would have the return air bringing the stale air back into the unit, that filters it at the unit, then conditions it hot or cold, blows it back out the supply. But you can easily have a supply air in fresh air intake added. And in fact, I spoke to the air conditioning company that did my ducted system. I asked them about that and they said, yeah, Rhys, easy. We could always come and do it for you anytime in the future. The other way to do it is to use a heat recovery ventilation, it's called. And you can go down the wormhole of Googling heat recovery ventilation, which is essentially anywhere from little tiny 200 by 200 in-wall units, which have 2 fans and a heat exchanger, and they run almost silently. I do think you require a minimum depth of wall. I think you need a 200 millimeter thick wall or you're going to have a protrusion, but you can install them in every room. I'm sure they're not cheap, but they work really efficiently. There's something like 90% energy efficient. And then you've got bigger units where you can actually install entire heat recovery systems. You may not actually want air conditioning in your home. You just want fresh air ventilation. And you can go anywhere from your little wall unit up to massive commercial systems. They do exist and people do have them installed in their home.
Yeah. Rhys, I think that's your wind-up call. And I'd like to thank you on behalf of the WinZero members for the valuable time and information that you've given us tonight. I've certainly learned quite a lot about things I had no idea I needed to know. And I just would again like to thank you, and I'll hand back to Richard, our chair, to close the meeting.
You're very welcome, Chris. It was an absolute pleasure.
Kay has her hand up.
This is the image of our kitchen ceiling, and it's done with a thermal imaging camera. The council has a thermal imaging camera. Chris has it at the moment, and she's returning it soon. It's quite an expensive camera, so they're trying to work out how to lend it out so it doesn't get lost. But the story here is we had a leak in our ceiling, and we had some insurance people come and have a look at it. So they pulled back the insulation, didn't replace the insulation. And of course, we hadn't gone up to check, but it highlighted the fact that we had these gaping, uninsulated spots in our ceiling, and we didn't know about it until we looked through the camera. The council also has a power kit, which Chris and I have just been experimenting with, and you can test mainly appliances with that kit. So there's 2 of those kits, and they also can be rented out. So we'll tell you more about that when we sort of sum up this and send out information for a wrap up. We'll tell you about hiring these cameras from council and the power kit.
Rhys, again, thank you. Chris, fabulous. Thank you again, Rhys. So to everyone, have a wonderful evening.